the least common multiple of each polynomial. So here we have x minus 2 times x plus 3 and 10 times x plus 3 to the second power. So we have to find the prime factors of each expression. So we'll start with this first expression. X minus 2 is already a factor because it's not divisible by anything other than 1 in itself. And x plus 3 is also a prime factor because it isn't divisible by anything other than 1 in itself. However, for this next expression, we have 10x plus 3 times 10 times x plus 3 to the second power. All right, let's see the prime factorization of that. Would be 2 and 5. And then the prime factorization of x plus 3 to the second power would be written as x plus 3 times x plus 3. So now the next step is to write each prime factor the greatest number of times it appears in either expression. All right, so here we have, let's just rewrite both expressions. X minus 2. Okay. X minus 2, then two times 5 times x plus 3 times x plus 3. All right, so 2 appears once in either expression. The prime factor 5 appears once in either expression. X minus 2 appears once in either expression. And then x plus 3 appears twice here, and then it appears once here. So we're going to put it the greatest number of times it appears, so that's going to be twice. And that's going to be our answers. And we can simplify 2 times 5 and just rewrite that as 10. Times x minus 2. Close parentheses and open parentheses, x plus 3 to the second power is going to be our answer. All right, our next one. 5y squared minus 80 and y plus 4. So let's start by what the prime factorization is for 5y squared. So let's first factor out 5 times y. Well, we already see 5 is going to be factored out. So 5y squared minus 80. So we're going to start by rewriting the expression. Then we're going to factor out 5 times y squared, because 5 is a common factor between 5y squared and minus 80. And 5 goes into 80 how many times? Is it 18? Let's see. 5 divided into 80. 5 goes into 8 once. Then we have 3 left over. 5 goes into 30 6 times, so it's 16 times, not 18. Minus 16. Now we see here we have the difference of squares. Y to the second power minus 16 is going to be 4 to the second power. So we're going to do 5 times 5 times y plus 4 times y minus 4. Now we still need to find the prime factorization. Now, 5 is a prime factor. It's only divisible by 5 in itself. Y plus 4. Can it be factored by anything else? No. But here, y minus 4. Can that be factored by anything else? No, there is no common factor between y and 4. And there is no common factor between y and negative 4. The next expression is y plus 4. Now we're going to write each prime factor the greatest number of times it appears in either expression. So 5 appears once between each expression. Y plus 4 appears once. And y minus 4 appears once. Which that could be rewritten as 5 times y squared minus 14 because of the difference of squares. Or we can just rewrite it as 5y squared minus 80. And that is our answer. The least common multiple between 5y squared and y plus 4 is 5y squared minus 80. And that is our final answer.